Okay, YouTube, in this video we're going to focus on how to solve equations that we say are in quadratic form but aren't necessarily themselves quadratic. So for instance, here in this checkpoint 6, you see that we have some fourth degree polynomial. That's definitely not quadratic, but I say that this is in quadratic form because this looks a little familiar to me. At least if I were to have an equation that looked like this, x squared minus 5x plus 6 equal to 0, then I would be much more comfortable with what I see, because I could say, well, yeah, two factors that multiply to be a positive 6 add up to be a negative 5, or negative 2 and negative 3. And we could factor it. So the fact that this is in what we call quadratic form means that what we can do is we can use a thing called a u substitution to help us factor that thing. So for instance, you see up here a couple of examples. We say x to the fourth minus 10x squared plus 9 equals 0. You could really look at this as x squared squared minus 10x squared, and I'll write this, x squared to the first plus 9, and we'd say no x squareds. So that is what makes this in quadratic form. So by doing a substitution, what we'll do is we'll say allow u to represent this x squared thing, which by the way has the value of this middle term if it's in quadratic form. But we could rewrite this as, instead of x to the fourth, we could say it's really x squared squared, which is u squared, and you'll see that here, u squared. Now minus, now we had minus 10x squared, but we're saying x squared is being represented by u. We say minus 10u plus 9 equals 0. And this would be something where we could say, well, then this would be u minus 9, u minus 1. And then we could just work backwards and say, well, if u represented x squared, then really we get x squared minus 9. We get x squared minus 1. And so this is totally factorable. And the same thing is very true with this example, including rational exponents. But I noticed that if it's in quadratic form, it's a trinomial. You tend to see that. And then we would say that this middle power on the variable is always half of the leading variable's power. And also we'd say what we'll use for our u substitution is just the value of that middle variable. So if u is the same thing as x to the 1/3, then we could really look at this 5x to the 2/3 as 5 times x to the 1/3 squared. Or in other words, 5u squared. Plus 11, now x to the 1/3, that's u, so we say plus 11u plus 2, and this equals 0. And now we can just solve this like a polynomial equation. We'll set it equal to 0 and solve it by factoring. So let's take a look at a couple of examples here, starting with this one right here. Now, if I said x to the fourth minus 5x squared plus 6 equals 0, I'm inclined to think that this is already in quadratic form. And we can certainly use a u substitution. I noticed that u we should probably allow to be this x squared, because that's our middle term, its variable value. But we could say that rewriting this then, we could say x squared, this first term is x squared squared, x squared squared, minus 5 times, and I'll write x squared to the first, plus 6 equals 0. So really this expression can be thought of as this. We would say that this is u squared minus 5 times u to the first plus 6 equals 0. And this would be really easy to factor. As a matter of fact, we say we get u minus 3, u minus 2. So this is true. And we could set each of these factors equal to 0, but what I want to keep in mind is, well, u was really just being used in place of x squared. So now we could write this as x squared minus 3, x squared minus 2, and set that equal to 0 and solve these. So just checking, I can't seem to factor these any further. So what we're going to do is we're now going to take each of these factors and set them equal to 0 and solve them. So I get x squared minus 3 equals 0. When we add 3 to the right side, we get x squared equals 3. So taking the square root of both sides. Remember, we're taking an even indexed root of this, so we have to have a positive and negative result. So we get plus or minus 3. And then over here, if we add 2 to the right side, we get x squared equals positive 2. Taking the square root of both sides of this, since we took the square root, we'll put a plus or minus in front of this, and we say just root 2. So the solutions for this equation, we say solutions. We want to write in set notation. We would say is the set containing positive or negative square root of 2, positive or negative square root of 3. So for a grand total of 4 answers. So now looking at this next example, we say 3x to the 2/3 minus 11x to the 1/3, which is half of that 2/3, minus 4 equals 0. This certainly looks like quadratic form. So I would say in this case we would allow u to be this x to the 1/3, this middle term's variable, and its power. And we could rewrite this as really 3u squared minus 11u minus 4 equals 0, and factor this. So now, this one is not so straightforward as much as this over here was, because we had a leading coefficient of 1. Since we have a leading coefficient of 3, remember, we'll just kind of guess and check till we get this to work. But I know that here and here, we would need to put a 3u and a u. Okay, and that's going to give us this first part of our FOIL. So now for the last part of our FOIL, we need two factors of a -4. So I'm just going to spitball here. I'll say like maybe +2 minus 2. And so what we need to do is say, well, that would give us the L part. That certainly would. But we need to check the outer and the inner. So I noticed that if I took 3u times a -2, I'd get -6u. I take a 2 times a u, I'd get a positive 2u. And this would give me a -4u, which is not what this middle term is. So perhaps we go back and we try other factors of -4, like maybe a -4 and a +1. So I'll check this here, and I say, well, let me rewrite this. 3u minus 4. U plus 1. Will this work? So we would say I get 3u times a 1 is 3u. -4 times a single u, there's -4u, and these add up to be a -u. So I still need a -11u here in the middle. So we'll try this again. This doesn't work. We'll say 3u and u. And what I'll do is I'll switch my 4 around here. Why don't we do this? We say -4 and +1. And I know this is going to work, but I wanted you to see that we play around with this. We say 3u times a -4 is -12u, and 1 times a u is a u, and we get -11u. So this is the factored form of our original expression. Now we said let u be this. So now what we're going to do is we're going to go back and substitute this value of x in for all of these u's, x to the 1/3. So we get these factors, 3x to the 1/3 plus 1, and x to the 1/3 minus 4. So now we're going to solve these individually by setting each equal to 0. So we have 3x to the 1/3 plus 1 equals 0, and x to the 1/3 minus 4 is 0. So let's do this. Let's isolate this base, just like we did in the last video. We need to get that rational exponent term by itself. So we'll subtract 1 and divide by 3. So I'm going to move a little bit quickly on this one, but we say if I subtract 1 and divide by 3, I'd have -1/3 on the right. And so now what we'll do is we'll raise both sides to the reciprocal power, which is 3 over 1. And so that's going to cause this to drop out, and we learn that x is equal to this -1/3 cubed, which is -1 over 27 when we cube the top and bottom of that. Now looking over here, we say adding 4 to the right side, we get x to the 1/3 is equal to 4. And exponentiating both sides to the reciprocal power again, we get x to the first is equal to 4 to the 3rd power, which would give us 64. So the set of solutions here would be -1/27 and a +64. Cheers.